Hi guys, so we're going to solve exponential and logarithmic equations given the three problems here. So if you look at number one, I'm going to write it out just so you can see it a little better. So it's going to be 3 to the x power equals 9 to the x minus 1 power. So if you look at the bases, which is 3 and 9, you want a number that you could raise to a power and get 3 and 9, but the bases should be the same. So, for instance, 3 to the x power, I'm going to leave as is. So 3 to the x power. And I'm going to note that if I raise 3 to the second power, notice it's the same base as the left side of the equal sign. If I have 3 to the second power, I will get 9. So the base has been replaced with 3 to the second power. Now the bases are the same. The x minus 1 I'm going to bring down. Make sure anytime you bring down something with a plus or minus, it's in parentheses so that that 2 gets distributed correctly. So why do we want it to have like bases? Because if they have like bases, you can technically just get rid of them. More specifically, let's say I were to put log base 3 on the left side, whatever I do to the left, I do to the right. Log base 3 of 3 is just 1. It gets rid of it, leaving you with x. And then log base 3 of 3 is gone as well, leaving you with 2x minus 1. So that's pretty much the proof of it. You can just remember if you have the same exponential base on both sides of the equal sign, you can just set the exponents equal to each other. And from here, I just have an equation to solve for x. So this is x equals 2x minus 2. And I want everything on one side of the equal sign to solve for x. So I'm going to move this positive x to the left, or from the left to the right. Keep in mind that if there's no number in front of x, it would be a 1 there. So 1x minus 1x would give me 0. 0 equals 2x minus 1x would be 1x, so we just leave it as x minus 2. So we have x equals 2. So this is your answer. And just for this problem, I'm going to show you that you can check your work. Same way that you have done in algebra. You just replace the x in the original equation with 2. So 3 to the second power equals 9 to the 2 minus 1 power. So 3 to the second power is 9. And on the right, I have 9 to the first power, which is also 9. So this works out. And for number 2, I'm going to write this out again just so you can see it a little better. Same idea. We want these two to have the same bases. So what number could I raise to the power to get 4, and I could raise that same number to a power to get 8? So that would be 2. So if I raise 2 to the second power, I'll get 4. And if I raise 2 to the third power, I'll get 8. So they now have the same bases. All of the exponents that you haven't used, make sure you bring it down, especially the one with x plus 3. It's an expression, so bring it down in parentheses. Once again, you have like bases, so you can get rid of that. Just set the exponents equal to each other. And from here, you just have an algebra equation. I'm going to bring down the 2x and just distribute the 3, leaving me with 3x plus 9 on the right side. And the goal is, again, just to make one side equal to 0 to solve for x. So this is a positive 2x. I'm going to subtract it and keep it balanced by doing the same thing to the other side of the equal sign, leaving you with 0 equals 1x plus 9. And in this case, x will equal negative 9. So for the third question, this would be 3 to the x plus 5 power equals 10. So notice the bases are 3 and 10. There's no number I can raise to a power to get both 3 and raise that same number to another power and also get 10. So when this happens, what you're going to do is you're going to look at the exponential base and give it a log of that same base. So remember what we did in number 1, log base 3 of 3, got rid of it, leaving me with just the exponent x. So log base 3 I'm going to put here just to get rid of this exponential base of 3. but it's algebra, so I can't just do one thing and leave it alone. It has to be balanced. So I actually have to put log base of 3 also on the right side of the equal sign. So from here, log base 3 of 3 is gone, leaving me with the exponent x plus 5 as just the left side's expression. And I have log base 3 of 10. Now, there's only one step left to get x by itself from here. So I'm going to subtract 5 to both sides. And that'll be x equals log base 3 of 10 minus 5. So how do I actually calculate this? A lot of your calculators don't have a log base of anything other than 10, which is why the direction states to use the change of base formula. So the change of base formula, to rewrite the log base 3 of 10, you take the log of 10 over the log of the base, always the base on the bottom, minus 5. And then you just plug it into the calculator. So log of 10 divided by log of 3, make sure you press equals and then subtract 5, and you should get approximately negative 2.9. All right, guys, hope this helps.